what Tesla noticed like very early on is that even if they had fairly good performance metrics during offline training and evaluation, they still run into issues in production. So in this case, production training data skew is not always avoidable. Um, and specifically, most of the areas of the data describing is around edge cases and more specifically out of distribution samples. So as you can imagine, if you're thinking about, again, about the use case, in self-driving car, edge cases are extremely important. You need to perform well all the time, and really you can't afford missing out on certain segments. And the challenge with edge cases, again, by nature, they occur fairly rarely. And this, of course, touches the high-level kind of concept of machine learning generalization. I will not try to attempt to solve this in this talk or even go too deep. But of course, for those of you who are not aware, maybe not proud, generalization discuss how will your model will perform in data that it hasn't seen during training. And there are approaches, offline approaches, to try to evaluate how your model is going to do that. For example, you can try to simulate out of distribution samples by withholding certain scenarios during training. But at the end of the day, all of these are just proxies and approximations. And out of distribution and edge cases can also pose a challenge with offline evaluation. So models can perform very well in aggregate, but not in edge cases. And offline evaluation strategies are fundamentally limited by the fact that they rely on historical data. So while it's key to have a robust evaluation strategy, at the end of the day, you need to deploy the model to production. Deploying to production is key. This is where the model needs to perform well. And so what Tesla did here, which is actually very interesting, is they deploy what they call shadow models, right? So the loose definition of a shadow model here is a model that's running prediction like any other model, but those predictions are not being served or really acted upon, right? So they're basically just storing the prediction in some kind of database. And then what they're doing is they're using weak signals and heuristics. For example, the autopilot disengages because the driver kind of grabs the wheel. And they label that using essentially weak labels as potential mistakes, and eventually downstream it helps them to identify model failures and edge cases. So they take these weakly labeled samples, they go through their data cleanup, processing, labeling pipeline. But what happens next is interesting, right? So I'm guessing a lot of you would expect, okay, I got a new set of labels. Let's just retrain the model, right? Well, let's make it completely automatic because we have a way of generating these weak labels. We can use human annotators to make them strong labels. Let's just run an automatic repipeline. But while clearly to solve this or improve this, you do need to retrain the model. It's actually not a trivial problem at all. And I'm specifically referring to retraining. Now, in this case, right, like how do you deal with these new auto distribution samples is actually crucial. It's a form of this like balancing act, right? So if you try to boost these new samples too much, you can start witnessing things like catastrophic forgetting, where, the model suddenly no longer performs in sample it used to when it can now, but it might do better on these what used to be out of distribution. So, thinking about the use case, it can now navigate roundabouts, but can maybe no longer drive in freeways. And if you don't boost these samples enough, the new task is not learned by the network. So the main point I'm trying to make here is that like what often people call today is like offline experimentation is not this thing that you do once, put in production, and then you have retraining pipeline completely autonomous. To be successful with machine learning, specifically in industry, you have to always bring back production data and results offline to like your workbench so you can build these better models.